maybe 12, 13, yeah, 12, 13 and 16. Right, okay, so 12 was just drawing the image of it in the line x equals y. Any issues with 12? Any one of you want me to do any of them? What I should have said yesterday as well, girls, you know, so we're reflecting in the line y equals x. And what happens is, if you reflect the likes of 3, 4 would be up here. So if you reflect that in the line y equals x, it goes backwards. So it becomes 4, 3. Sorry, yeah, do you know what's wrong? It's magnified and this is all out of sync. Yeah, okay, so if you reflected something like 3 naught in the line, right, okay, you'll actually get naught 3. Okay, so whatever point you get, if you reflect it in the line, it turns it backwards. So 2, 3 becomes 3, 2. 1, 2 becomes 2, 1, etc. Is that alright? That probably would have helped you last night a lot. Right, okay. But is there anyone in number 12 you want me to do? No? Right, 13? Yeah. Right, okay. So number 13 is, in the given diagram shows the lines L and M, find the equations of L and M. Girls, this coordinate geometry. Okay, so L, I'll go with L first, and we have 2 points on L, minus 4, 0, and 2, 2. So you have to get the equation of the line, so before you get the equation of the line, you have to get the slope of the line. Okay, so slope formula is y2 minus y1 all over x2 minus x1. So this is x1, y1, x2, y2. So that's 2 minus 0 all over 2 minus minus 4. Okay, tidy that up, cancel it down. It's 2 plus 4, 2 over 6, 1/3. Is that right? Okay. So then our equation formula y minus y1 equals m into x minus x1. So use either point. So I'll just use this one.
Excuse me please, if Sheena and Siobhan or Ketchua could come to reception now.
Y minus 0 equals a half into x minus minus 4. Okay, to sort out that, you bring the 2 up at this side, leave the 1.
Is it not a third?
Oh, sorry, it is. I don't know why I changed it to a half. Thank you. X plus 4. So that's 3y equals x plus 4. So you can rearrange it so you've everything equal to 0. So it's x minus 3y plus 4 equals 0. But in reality, in the exam, if you got to here, well, you get full marks. Okay, so you don't need to sort it out unless you have to use it. I guess I'll have to use it for something in a minute. Right? Okay, is that right? Okay, so yeah. Do you know there was an easier way of doing that? I'll do the other one with the easier way. Okay, so you know.
Excuse me please, Ava Downey to reception.
The other line has the point 0 minus 4, right, and the point 2, 2, right. This is the point where it intersects the y-axis. Agreed? Do you know what? I won't do it the other way because it'll just confuse you. If you spot it, you spot it. If you don't, I'll just do it this way. Right, so we're going to get the slope again. So here y is equal to y2 minus y1 minus minus 4 all over x2, oh for God's sake, where am I? Y2 minus y1 all over x2 minus x1. Okay, sorting all that, you'll get 3. Right, okay, agreed? Am I right? Okay, and then filling in this formula, I'll use this, so it's y minus minus 4 equals 3 into x minus 0. Okay, so that's y plus 4 equals 3x And girls, what I'm going to do is, because I'm dealing with functions and I have to do the inverse of the function in a minute, I'm going to rearrange this so I just have y equals 3x plus 4. And I might do the same to the other one, okay, because you know I'm dealing with functions, so I actually want f of x equals 3x plus 4. Does that make sense to people? Is it minus 4? It is. There's another, Emily, you're passing all the tests today. Right, okay. Right, so it's minus 4. Okay, are we okay? Right, okay. This one, I'm going to rearrange so it's got y equals as well. So I might skip that line. Okay, and you know I was here 3y equals x plus 4, so y equals x plus 4 all over 3. Yeah? Okay, so the reason I'm doing that is because I can replace y with f of x. Is that okay? So then I have to get the inverse, so I have to show that one function, part 2 says I have to show that one function is the inverse of the other. I think this one is the easiest to get the inverse of, isn't it? Right, it really doesn't matter, okay? So this is y equals 3x minus 4. So I wanted x equals, so that means 3x is equal to y plus 4. So that means x is equal to y plus 4 all over y plus 4 all over 3. Replace x with f inverse of x and replace the y with an x plus 4 over 3, which is the same as the other function, so that's approved. Alternatively, you could get the inverse of that function and end up with y equals 3x plus 4, or f inverse equals 3x minus 4. Is that alright? Okay, so you just need to get the inverse of one to show it gets the other. Is that alright with number 13? Are we okay? Right, okay, and then you had number 16. Number 16? Do I need to do it? Yeah, do it. Okay. Say that again? Yeah, okay. I see you're still writing, sorry. Okay, am I good? Good? Right, okay, so next one is number 16. Given that f of x equals x plus 3 over 2, x is an element of 0, 5, so that means x is an element of, that's the domain. Remember, the square brackets mean 0 is included and 5 is included. That's what the square brackets mean. Okay? Where am I? Find f inverse of x. So this is y equals x plus 3 over 2. Cross multiply 2y equals x plus 3. X equals 2y minus 3, replace the x with an f inverse of x and turn the y back into an x, so it's 2x minus 3. Is that okay? First bit. Okay, next bit. By drawing graphs of that in the given domain, show that the domain of f is the range of f inverse. Write down the domain and range of f inverse. Right, so we have to sketch them. Right, okay, so in order to sketch, they said 0, 5, so I might do f of x first. Okay, so f of x when x is 0, 1, 2, 3, 4, 5. It's actually a line. Two of these points will do, but I'll just get them all for the moment because you can do them on the calculator. Is that alright? So you can put in your function x plus 3 over 2. Right, put in your start is 0, your end is 5, and go in one step and then you fill it in. So you get 0, 3 over 2, 1, 1, 2, 2, 5 over 2, 3, 3, 4, 7 over 2, and 5, 4, yeah? Okay, so I'll get the corresponding points for f inverse of x. So again, I'm drawing this function. So I'm going 0, 1, 2, 3, 4, 5, okay, and 0, where am I? Minus 3, 1, minus 1, 2, 1, 3, 3, 4, 5, 5, 7. Yeah? Is that okay? Yeah? Yeah. So look, I know they said to draw it, but I'm just going to say, see, they're the reverse, aren't they? 4, 5, that's reversed. Right, 2, 1 should be on this list and 1, 2 is on that list. There you go. So there's 3 points reversed, so that means they are the inverse of each other. That's the reflection of 1 in the line y equals x. They said draw it, so draw it, but I'm not drawing it. Is that alright? Is that okay? Right. And then it says, write the domain and range. Oh, right, okay. So the domain and range of which am I writing? The domain and range of f inverse. Write down the domain and range of f inverse, right? So the domain is 0, 5, and the range is minus 3, minus 1, 1, 3, 5, 7. Is that, yeah, that's all. Yeah, is that all right? Okay, right, that's all you have to do there. That's grand. Right, okay, are we good? Yes. Sorry, what's the minus the range is all the y values, minus 3, minus 1, 1, 3, 5, 7. The domain is all the x values, and the range is all the y values. Right, are we good? Right, okay. I want to do one more example on that section before I move on to the next section. Right, okay, so where did I finish yesterday? Example what? Oh, hang on. I forgot I did this. I'm going on to 5. We just did 5. So I'm doing 6, yeah? Okay, so here's example 6. I forgot I got carried away a while ago. Example 6. Right, find the inverse of here, this function. Right, in order to get the inverse of a function, what did I say the function had to be? What word, fancy word did I say? In order to get an inverse of a function, I said the function had to be bijective, yes? Right, so you remember that? Right, you do now. Right, so in order for a function to have an inverse, right, it has to be bijective. Right, so bijective means when you do the horizontal test, it hits it exactly once. Right, so surjective is at least once, injective is at most once, bijective exactly once. Okay, so if you were to draw that, okay, it would be a U-shaped graph, agreed? Okay, so if you were to draw that, it would be a U-shaped graph. That is definitely not bijective. Would you agree? That is not bijective. But if they limit the range or the domain, so they limit the x values, so basically they're halving the graph. Okay, so the graph is going to start at 2 and it's going to go up like that. Right, okay, and now it's bijective. Okay, so that's what this is about. Okay, so they've limited the domain, as in limited what x values you put in, so to make it sure that the graph is bijective, because if that wasn't there, you couldn't get the inverse of that because it's not bijective, right? But if you limit the domain, if you limit the x values, it is bijective, right? Is that okay? You don't need to do anything with that. I'm just explaining why it's there. Okay, is that right? So you don't need to do anything with that. Okay, now I want to rearrange. So this is y is equal to x squared minus 4x minus x. Okay, so I want to rearrange it so I have x equals. Now, you know, normally we put all the x terms on the one side and the y, everything else on the other side, and then you take out an x out of the bracket. You will never be able to get that down to 1x, right? Okay, as in, like before we would have went to x squared minus 4x. Well, what we would have tried to do is y plus 6, and then normally I would take out an x because I want to isolate the x, but when I take out the x here, I'm left with x minus 4. So when I rearrange, I'll end up with y plus 6 all over x minus 4, and that's not good enough. All the x's have to be on one side. So it's not possible to do it that way. So basically, they're telling you how to do it. So in order to isolate the x, right, okay, so to have x on its own, you need to complete the square, right? So that's what they're telling you, complete the square. So we want to find the inverse, so that means we want x equal to everything else. So the only way you can isolate that x is to complete the square, right? How's your memory with completing the square? So you take the first term, you take the second term, you have the coefficient of x. So the coefficient of x is 4, have it, you get 2, and you square it. So square 2 and you get 4. So that means I'm adding 4, but I can't just add in a 4, I have to take it out again. Right, and then there was a minus 6 at the end. Do you remember completing this square? Right, okay, so you have the coefficient of x, square it, add it on, subtract it. Okay, then the first 3 terms you factorize. So it's always going to be a perfect square because you just arranged for it to be a perfect square. So it's x and x, 2 and 2, a minus and a minus to give you a minus 4x. Is that right? Put these 2 terms together and you get minus 10. So I get x minus 2 2b squared equals, minus 10, and that's what y equals. Right? So now I have to rearrange that, right? Rearrange that so I have x equals. Okay? So I leave the x minus 2 to be squared over there, right, and I'll bring y plus 10. What I do now, get the square root of each side. So when I get the square root of this side and square root of that side, I'll get here, I'll just get x minus 2, and over this side I'll get the square root of y plus 10. Okay? So that means x on its own is equal to the square root of y plus 10 plus 2. So I've isolated x on its own, right? If I did it my normal way, it wouldn't be possible to do it, right? So they told you how to do it, complete the square, right? So x is on its own, and remember then, you replace x with f inverse of x, and you turn that x, or that y, back into an x plus 10, right? Plus 2. The plus 2 is not under the square root sign. Now there's one done, that's it done, right? But you have to, there's also a limit on what you can put in here, right? So you know the way you cannot get the square root of a negative number, agreed? So in order for that number, in order for the number under the square root sign to be positive, so you want it to be 0 or more, agreed? What does x have to be? So if x is minus 10, it's fine, isn't it? Square root of 0. If x is minus 11 or minus 9, it's fine, isn't it? Because square root of 1. If x is minus 8, it's fine, isn't it? You're getting the square root of a positive number, right? Okay. But if you go less than minus 10, as in if x was minus 11, what would I be trying to get the square? If x was minus 11, what would I be trying to get the square root of? Minus 1. Can't do it. If x was minus 12, I'd be trying to get the square root of minus 2, which you can't do. So what you need to do is you need to look at that and say, well, in order for all of that to work out, x must be greater than or equal to minus 10. Isn't that right? So it can be -9, -8, -7, any number like that. Okay, but if it go less than -10, right, we're trying to get the square root of a negative number and that doesn't exist. Right? How do you know when you have to look at it and see, do you have to limit the domain? It's because it's when they limit the domain going in. Chances are, if you limit the domain going in, you'll have to limit the domain when you get the inverse. Is that okay? Does everyone understand that? Is that okay? I'll give you a few of those for homework tonight, okay? But I need to move on to the next section. Are we good? Right, okay. The next section, you'll be delighted to hear there is absolutely nothing new in it, right? So the next section, we've done it before, you've done it last year, or no, you haven't done it last year, you did it in third year, right, okay? And we would have touched on a lot of this when we did algebra as well, okay? So the next section is just about sketching graphs. So I'm really just reminding you what's going on, right? There's nothing new here. So we have to learn how to sketch 3 types of graphs. We have to learn how to sketch linear graphs. We have to learn how to sketch quadratic graphs. Remember, a quadratic graph has an x squared term. Linear function just has an x in it. Quadratic has an x squared, and a cubic graph, which is an x cubed term in it, right? And as I say, we did them all in algebra, so we're really just revising, okay? Right, so if I have a linear function, right, so instead of saying y equals ax plus b, I just said f of x equals ax plus b. So a line, girls, has an x term in it. Nothing higher, no higher variable than x, right? Okay, so there's no x squared, no x cubed. The highest power of x is x on its own, right? So for example, 2x minus 3, 7x plus 1, right? 8x minus 4, they're all linear functions. And when you draw a linear function, what do you end up with? A line, straight line. Linear means line, right? Okay, so if the number in front of x is positive, right? Okay, so if this number, remember this is from a coordinate geometry of the line, this is in the form y equals mx plus c. So it's in that form. So the number in front of x is the slope. So if the number in front of x is positive, as in if it's greater than 0, it's a line going up, right? Okay, and if the number in front of the x is less than 0, as in if it's a negative number, you'll end up with a line going down. It's always a good idea to know what you're going to end up with, right? Okay, so if that number is positive, it's a line going up, and if that number is negative, it's a line coming down. Is that all right? Right, in order to, now the reason we're doing this section is we want to end up with a sketch of the graph. So in order to sketch a line, girls, you need 2 points on the line. So sketch means a rough diagram, okay? So it's not an accurate graph. If you're doing an accurate graph, you'd probably put it into a calculator and get lots of different points, okay? But a sketch, you just want a kind of a general feeling of the shape, right, of the graph. So to sketch a line, find 2 points on the line, right? Any 2 points on the line, right? The easiest points to find are normally where it cuts the x-axis. So the rule cuts the x-axis, let y equal 0, get a point. And then find out where it cuts the y-axis by letting x equal 0 and get another point. They are normally the 2 easiest points to find, right? But you can find any 2 points. You could let x equal 1, find out what y is. You could let x equal 10, find out what y is, okay? Right, but these are just the ones we learnt in third year, and they're the easiest ones to find most of the time, unless the line goes through 0, 0, and then you have to come up with another point, okay? Right, example. Right, are we okay? No, I'll wait a minute. I'll need to catch up. See, I'm not writing, so I don't know how long it's going to take you to write it, so shout at me if I whip stuff away and you're not ready. say? I don't know what that says. Right, okay. Are we grand? Are we good? Right, okay. Next one. Right, example 1. So you want to sketch this. It's a line. You know, you need to know by looking at it, it's a line, because there's no, the highest power of x is x on its own. That means it's a line. Is it a line going up or a line going down? It's a positive slope, isn't it? So that means it's a line going up, right? Handy to know what you're looking for, right? Okay. So the easiest 2 points are I said are to let x equal 0. So let x equal 0. So everywhere I see an x, put in a 0. So 2 times 0 minus 4. So that means y is equal to minus 4. So there's 1 point, 0, 4. So x is 0, y is minus 4. Okay? And then the second point that's easiest to get is to let y equal 0. So into the equation, everywhere I see a y, put in a 0. So 0 equals 2x minus 4. Solving that, you get 2x equals 4, so x is equal to 2. Is that right? So point x first, 2, 0. Okay? And then your sketch. Okay? So as I say, it's a sketch, so it doesn't have to be accurate. You're just getting a feeling for the general shape and where it crosses the axis. So minus 4 and 1, 2. So I have to go 2, 0, 0 minus 4, right? And there I have a line going up, right? Which I knew I was going to get. Is that all right? Right, you agreed that's revision? Right, are we good? So that's how you sketch a line. You need to get 2 points on the line, right? Okay, and you sketch, right? And you should know what kind of a line you're going to get before you start. It's very handy to know that, right? Okay, are we good? Right, this next thing you need to be able to sketch is a quadratic function. So quadratic function. And a quadratic function, girls, has an x squared term and then maybe an x term, maybe a number. So this one and this one, the x term and the number are optional. They may be there, they may not be there, but the x squared term has to be there. Okay? So x squared term, right? And you know this. If the number in front of x squared is greater than 0, as in if it's positive, what shape graph? Happy face. And if a is less than 0, as in a is negative, when it's negative, you're all down in the dumps and everybody's sad face. Okay? So I'll leave you right. Right, okay. So in order to sketch the graph, it's good to know what you're going to end up with, happy face, sad face, right? To sketch the graph, you need to solve it to find where it cuts the x-axis. Because you know if you solve, right, okay, you find the points where it cuts the x and y axis. Now it could be a happy face, you still don't know, you need this bit to know whether it's a happy face or a sad face, right? Find where it cuts the y-axis, so you would find this point also, right? Okay, so you'd find where it cuts the x-axis, let y equal naught. Find out where it cuts the y-axis, let x equal naught. I'll keep going because we're finishing early if that's okay, right? Find where it cuts the y-axis and complete the square to find the minimum or the maximum point. It's going to be a minimum point if it's a happy face, it's going to be a maximum point if it's a sad face. So I'll remind you of how to do that in a minute, right? Okay? Right, so complete the square to find the max or the minimum point. When we have calculus done, we'll have another way to find the max or the min, which is slightly easier than completing the square, right? But for the moment, complete the square. Okay, is that right? Okay, are we good? Gone? Okay, right. Sketch the graph f of x equals x squared minus 8x plus 9. Remember, that's another way of saying y equals x squared minus 8x plus 9. So you want to find out where it cuts the x-axis and where it cuts the y-axis. So cuts x-axis, y is naught. Y equals naught. Sorry, before I start, I should have said happy face, sad face. Happy face. It's going to be a happy face. It's good to know before you begin what you're going to end up with. Right? So let y equal naught. So everywhere I see y, put in a naught. X squared minus 8x plus 9. Okay? So factorize x and x, 9 and 1, a minus and a minus. No, that couldn't be. I probably wrote that down wrong now because that doesn't work out. Hang on a minute. That's wrong anyway, isn't it? Sorry? Yeah, it has to be, I have to change that to a minus. Right, okay. Don't I? So I have 9 and 1, two different signs, so it'd be minus 9 and then a plus 1. Yeah, I think I just wrote it down wrong. Right, is that okay? I think it's good now, is it? Let each bracket equal naught, so you get x equals 9 and x equals minus 1. So there are your 2 points where it cuts the x-axis, as in 9 and y was 0 and x is minus 1, 0. Is that okay? Then we need to find out where it cuts the y-axis. So what's the rule for cuts the y-axis? X is naught. Right? So cuts the y-axis, x equals naught. So into the equation, everywhere I see an x, put a naught. So you get y is equal to naught squared minus 8x minus 8 times naught plus 9. So that works out. So that works out to y equals 9. So that's another point. So x is...
Miss, is it not minus 9? Or
Oh yeah, because I changed it, didn't I? Yeah, minus 9. Sorry, that should be a minus 9 up there. And that's a minus 9 here. Is that okay? So that should be a minus 9. So that's the point. X is 0, y is minus 9. Okay? Right. Finally, I have to find the max or the minimum point. Which is it going to be in this case? Minimum, because it's U-shaped, so it's going to be a minimum. Right, okay, so to find the minimum point, you complete the square. So it's x squared minus 8x, right? Halve the coefficient of x, so halve that, it's 4, and square it, so that's plus 16 and then you must put in a minus 16, and then there's a minus 9 at the end.
You can't do it.
Okay, sorry, is it okay if I do that? Right, okay, so the first three will end up being x minus 4 by x minus 4, which is a perfect square, which is what you planned it to be, because you completed the square. Okay, minus 23. Okay, the minimum point, girls, is always the opposite sign, same sign. So the minimum point is 4 minus 23. Is that okay? So the minimum point is 4 minus 23. I'm going to have great crack on this. Okay, so just U-shaped graph. My points so far are... Oh yeah, I can't add. Okay, minus 25. Okay, there's another person acing the test while the rest of you don't. 0 minus 9, right? 4 minus 25. I'm just listing the points on this. So 9, 0 and minus 1, 0. And I know it's going to be a U-shaped graph, okay, from the very start. So graph, so I have minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I haven't a notion of going down to minus 25. I picked a bad example, to be fair. Minus 3. I'll go to minus 9, minus 4, minus 5, minus 6, minus 7, minus 8. I can't even go to minus 9. So let's draw what I have. 0 minus 9, across 0 down to minus 9. 4 minus 25, it's way off down there. Okay, I'll just do an arrow. It's way down there. Is that alright? Okay, don't bother drawing it, it's fine. I picked a bad example, but you get the idea. 9, 0, minus 1, 0. Okay, and then I'm drawing my U-shaped graph, so it goes way off down there, and then it comes back up, and it goes like that. Is that right? Okay, so it's way off down there at minus 25. I haven't a notion of drawing it. Okay, but we get the idea, yeah? We all good?
Excuse me, please, would Victor 4 go to Knapsack Lodge now, please? Also, would April Higgins come to reception at the bell, please? Thank you.
Okay, so we get the idea, yeah? Yeah? Okay, right. Finally, cubic functions. So, cubic functions, right? Okay, so here we go. You can write this down and then I'll talk about it. Again, we've done the cubic functions when we were doing algebra. If you can't read that, I'll call it out to you. If I half rubbed it out.
Can you read it real quick?
It says solve to find where it cuts the x-axis. And then let x equal 0 to find where it cuts the y-axis. Okay. Right. What I meant to do up here, girls, if a is greater than 0, as in there's definitely an x cubed term, the rest of them are optional, they may or may not be there. But if the number in front of the x cubed is positive, as in it's bigger than 0, we finish on a high, don't we? And if the number is less than 0, we finish on a low. Okay, so you're down in the dumps. Is that right? Okay. Am I good? Going on. Right, example 3, sketch. Now, you know the way, sorry, I should have said, you know the way this is called a local max and a local min. This will be a local min and a local max. We don't know how to get them yet, right? When we do a chapter later on in 5th year, we'll be able to get those, but for the moment we can't get the turning points. So we'll be guessing where they are, okay? So we're just going to learn to sketch with what we know. Okay, so example 3, sketch the function. Here we go. Right, so you need to solve. So you need to let y equal 0 and solve for x. So we'll end up with x cubed minus 2x squared plus 5x plus 6 equals 0. Right, in order to solve this, we have to use the factor theorem. As in, you guess the first factor and then you take it from there. So you see, right, does x equal 1, is x equal 1 a solution? So you'll go 1 to be cubed minus 2 times 1 to be squared plus 5 times 1 plus 6, and does that turn out to be a solution? 1 minus 2, 1 minus 2 minus 5. Right, I don't think that works out to be 0. I don't think that's the solution. Is that okay? I think that works out to be minus 1 for 10. I think that works out to be okay, but it's not equal to 0 anyway. So then you check out x is equal to minus 1. So that's minus 1 to be cubed minus 2 times minus 1 to be squared plus 5 times minus 1 plus 6, and you see, does that equal 0? That's minus 1, minus 2 is minus 3, minus 3 minus 5 plus 6. Oh, I've probably written this down wrong now because this isn't working out either. Where did I find this? Do you know, there should be a minus in front of that. Okay, so there's a minus in front of that, there's a minus in front of that, and what works out, minus 1 works out then. So if there's a minus in front of that, x equals 1 still doesn't work out, but minus 1 works out, because that would be 1 take away 2 is minus 1, minus 1 minus 5, yeah, that works out to be 0. Okay, sorry about that, girls. Right, there's a minus in front of the x cubed. That means it finishes on a low, so it starts high, finishes on a low. That's what we're ending up with. Okay? Right, if x equals minus 1 is a solution, that means x plus 1 is a factor. Remember the factor theorem? Vaguely. Then we have to do division. I'm going to use the box because I have a limited amount of space here. But you do your division your way, whichever way you prefer. X plus 1. This is minus x cubed and plus 6. So that would be minus x squared minus x squared, that would be minus, that would be a minus x squared. This would be minus x, so that's plus, no, that's minus 1x, and that's plus 6, so that would be plus 6x. Yeah, I think I'm good. Okay, right, so you do your division whatever way you need to do it, okay, right, so you end up with minus x squared so that would be minus x squared minus x plus 6. So you need to solve that, take out the minus, so x squared plus x minus 6. So the factors of that would be x and x, 3 and 2, a plus and a minus. There's a minus in front, and then at the end there's x, where is it? X plus 1, isn't it the other factor? Is that alright? Okay, so that means it crosses at minus 3, it crosses at 2, and it crosses at minus 1. Okay, finally, the second thing I need to do is find out where it cuts the y-axis. So cuts the y-axis, x equals 0. So it's y is equal to minus 0 cubed minus 2 times 0 squared plus 5 times 0 plus 6. So that turns out to be y equals 6. So that's the point. X is 0, 6. Sorry, I should have written the points 3, 0, minus 3, 0, 2, 0, minus 1, 0. Okay, so then sketch. Okay, I'm squashing it in here. So I need minus 1, minus 2, minus 3. So it crosses here, it crosses here, and it crosses at 2. It also crosses at 0, 6. So 1, 2, 3, 4, 5, 6. Okay, so it goes through that point there. Okay, and I've already decided it's finishing on a low, so that means it starts high. So here we go, around like that, and down there it goes. Right, I don't know how deep these, I don't have a max and a min point, so I don't know how deep those curves are. Right, I could have went right down, right, or I could have went right up, I don't know. Right, but you just go anyway at all, right, because you have all the information you're able to get at this stage. Is that right? Okay, are we good? Sketching? Right, okay, how am I going? Yeah, I might as well just give you a homework now because so we're going to do completing the square ones, so page 252. So like the example 6, I think, was it, that I did today? Just do parts 2, 3 and 4, because I did part 1. Okay, and then on page page 259. Let's do 4, 5, 6, 12. That's a 6 there. It looks nothing like a 6, but that's what it said. 6, 4, 5, 6 and 12. Okay, so it's 259 up to 260. Okay. Oh, and girls, you may have noticed on Teams, I put up a list of things you're supposed to know from Junior Cert. Okay, so I think it was a parent was talking to me about it on the parent teacher meeting. I don't know whose parent it was, but I said I'd do it, and I said give me about a week to do it, and that was 2 weeks ago. But look, I got there. Right, okay, so it's up there, and it's not exhaustive, as in there's probably things that you're supposed to know that I didn't put in the list. But it might be a good idea when we start a chapter just to go down through the list on that topic and say, well, I can do that, I can do that, I can do that. Oh, I can't do that, I need to go back over it. Right, because these are the things I'm going to assume you know. Right, is that all right? Okay, right. Photos, you want photos, I presume? Do you? Right, okay. Yeah. So 252, number 17.